Microservices. You've probably heard the term thrown around. It's one of the biggest shifts in how modern software gets built, an approach that's pretty much changed how every application we use is put together. But what is it, really? And, maybe more importantly, why did we even need it in the first place?
Well, it all starts with a pretty wild question. Why would some of the biggest, most successful tech companies on the planet voluntarily decide to tear down their massive, working applications and just start over from scratch? I mean, it sounds kind of insane, right? But they were all facing a huge problem that was slowing them down, costing them a fortune, and making their entire systems incredibly fragile. That problem had a name: the monolith.
For decades, this was just the standard way you built software. And a monolith is exactly what it sounds like: one big, single, unified block of code. In the beginning, this is actually great. Everything's in one place, it's pretty simple to develop, and it's easy to deploy. But that simplicity is really deceptive, and it definitely has a shelf life.
See, as an application grows, that monolith starts to crack under its own weight. The code becomes this tangled mess, so big that no single developer can possibly understand it all. A tiny bug in some minor feature can crash the entire system. And what if just one little part, say the shopping cart, gets really busy during a sale? Well, you have to scale the whole application, which is a massive waste of resources. This right here, this is the breaking point that forced a revolution in how we design software.
And that revolution was, you guessed it, microservices. The core idea was, instead of building one giant application, let's build a bunch of smaller ones that all work together. So the big idea here is that each microservice does one thing, and it does that one thing really, really well. Think about an e-commerce website. Instead of one big blob of code, you have a separate service for user accounts, another one for the product catalog, another for the shopping cart, and so on. Each one is its own self-contained unit, and they communicate with each other through well-defined APIs. You can think of an API like a restaurant menu. It lets each service order exactly what it needs from another service without having to storm into the kitchen and see how the food is actually made. And when you do this, the benefits are huge. All of a sudden, you can scale just the one service that needs more power. If the recommendation engine fails, who cares? The rest of the site can stay up and running. Teams can deploy their updates independently, multiple times a day, without some massive high-risk weekend release. They can even use different programming languages, picking the absolute best tool for each specific job.
Now this all sounds like the perfect solution, doesn't it? Well, here's where the story takes a sharp turn. All of that power and flexibility, it doesn't come for free. In fact, it introduces a whole new world of complexity. This quote just perfectly captures the core trade-off. You've solved the problems that come with having one giant system, but in its place, you've created this complex, sprawling web of interconnected services. And managing that web, that is the new challenge.
So let's break down what these new problems look like. Instead of managing one application, you're now juggling dozens, maybe even hundreds. How do you possibly keep data consistent when it's spread out all over the place? How do you trace a single user's request when it bounces between 5 or 6 different services just to get a response? And every single one of those network connections between services is a new potential point of failure and a new door for attackers to try and break in.
A huge piece of this complexity is just, how do these services talk to each other? Think of synchronous communication like a phone call. You call the payment service, and you have to wait on the line, holding, until it gives you an answer. If it's slow, you're just stuck. Asynchronous, on the other hand, is like sending a text message. You send the order, and then you just move on with your day, knowing the shipping service will get to it eventually. Now, that text message approach is way more resilient, but it creates this strange new problem. You have to trust that all the data will eventually sync up and be correct. Eventually. This is called eventual consistency, and it is one of the absolute hardest parts of managing these distributed systems.
And listen, these aren't just theoretical problems. When distributed systems fail, they can fail in absolutely spectacular fashion, as some of the world's biggest companies have learned the hard way.
100 million. In 2019, that's how many Capital One customers had their data exposed in a massive data breach. And this wasn't because microservices are inherently insecure. The failure was actually much simpler and much more human.
What's so fascinating here is that the architecture itself didn't fail. Instead, a single firewall, a really key security component, was simply misconfigured. This tiny human error opened a door that allowed an attacker to get access to incredibly sensitive data. It's a powerful lesson. In a distributed system, your security is only as strong as your operational discipline.
The 2022 Uber breach tells a very similar story. It didn't start with some sophisticated hack. It started by annoying an employee with login notifications until they got fed up and just approved one. Once inside, the attacker found the ultimate prize: administrator credentials that were carelessly left hard-coded right inside a script. That's the digital equivalent of writing your master password on a sticky note and leaving it on the server. This one single, basic security mistake gave them the keys to the entire kingdom.
So when you look at these incidents together, a really clear pattern starts to emerge. From Capital One's misconfiguration to DoorDash's cascading failures, the problem isn't the idea of microservices. The failures happen in the execution. Poor configuration, weak security practices, and just a general lack of the right tools to manage all the complexity of a distributed system.
Okay, so if microservices are this complex and this risky, what's the path forward? It requires moving beyond just the technical nitty-gritty and adopting a deeply strategic mindset.
You know, success here really comes down to discipline. It means designing services that map directly to your business needs, not just technical ones. It demands a heavy investment in automation and monitoring to tame all that operational complexity. Security can't be an afterthought. It has to be baked in from day one, with super strict rules, like granting each service only the bare minimum permissions it needs to do its job. And maybe above all, it requires pragmatism, recognizing that sometimes, for some projects, a simple monolith is still the right choice.
And that brings us to the ultimate takeaway from all of this. The debate isn't really about monoliths versus microservices anymore. The future of software is distributed, plain and simple. The real challenge and the real opportunity is for organizations to develop the culture, the discipline, and the tools to manage that distributed complexity effectively. That is the new frontier.